Hello everyone, welcome to the fifth video of concrete technology. In last class, in the fourth video, we have discussed the physical tests of cement water cement ratio and the effect of water cement ratio on strength of the concrete, and then we have discussed different factors which are affecting the workability. So that was last class. In today's class, we are going to discuss the methods of determining the workability of concrete. There are three different methods. We will discuss them in detail, and then we will briefly discuss the good qualities of an ideal aggregate. So let's start with the methods of determining the workability. Okay, so for determining the workability of any concrete, we got three different methods. First is slump test, and then compaction factor test, and then Vee-bee consistometer. Actually, slump test, we used to do slump test where the workability of concrete is high or medium, and compaction factor test, we prefer this test when the workability of concrete is low, and then if the concrete is very dry, then we prefer Vee-bee consistometer. And let me tell you about the units too. We do the slump test and we get results in millimeter. For compaction factor test, it's actually factor, so it is unitless, and Vee-bee consistometer, we get results in time, in seconds, which is called Vee-bee seconds. So let's start with the first test, slump test. So this is the apparatus for the slump test, and it consists of this is the device which we will use for the slump test, and the dimensions of this device is 20 centimeter dia at the bottom, 10 centimeter dia at the top, and the height of this apparatus is 30 centimeters, and we measure the slump with a scale. This is called slump cone, right? We need to remember the dimensions of the slump cone. They are actually important when it comes to the competitive exam or multiple choice question exam. 10 centimeter is the top dia, 20 centimeter is the bottom dia, and 30 centimeter is the height of the slump cone. So this is the scale, and we can hold this by hand, or we can provide a stand to hold this rod, which is actually perpendicular to the scale. So this test is carried out with a mold called slump cone. This mold is called slump cone, whose top diameter is 10 centimeter. As I already told you, the bottom diameter is 20 centimeter and the height is 30 centimeter, as shown in this figure. So let me tell you some important steps while performing the slump test. The first thing we do is to place the slump mold on a smooth flat surface. This is the smooth flat surface, and it should not be an absorbent surface. Then the second step is to mix the dry ingredients of concrete thoroughly till a uniform color is obtained, and then add the required quantity of water. Okay, actually this is the method of making the concrete mix. And in the third step, place that mixed concrete into the mold to about 1/4 of its height. It's 30 centimeter height. We need to fill it up to 1/4 of its height, and then compact that concrete 25 times with the help of tamping rod. We need to temp the concrete which is filled to the 1/4 25 times, the first layer. and then place the mixed concrete in the mold to about half of its height and compact it again, and then fill it to the half, and then in same way compact it again with the tamping rod for 25 times. Similarly, place the concrete up to its 3/4 height and then up to its top. So we are going to put it in 4 layers and repeat the same process of tamping 25 times each layer. And then in next step, we need to strike off the top surface of mold with a trowel or tamping rod so that the mold is filled to its top. And then in next step, we will remove. This image is showing the steps. And then we will remove the slump cone immediately, ensuring its movement vertical direction. Its movement should be vertical direction. Make it ensure. And then when the settlement of concrete stops, measure the subsidence of the concrete in millimeters, which is the required slump of the concrete. After removing the cone, then wait for some time for the concrete to settle down. After that, we will measure with the scale the height difference between the top of the cone to the top of the concrete, and that this difference or this height will give us the slump value. So slump test, we prefer slump test where the concrete workability is medium or high. Slump test is preferred where the workability of concrete is medium or high. And the next test is compaction factor test. We prefer this test for workability of concrete where its workability is low. So according to this test, the workability may be defined as the amount of applied work required to compact the concrete to its maximum density. Got it? So we got 3 different conical hoppers. These all 2 are conical and 1 is cylindrical, A, B, and C. So the apparatus required for performing the compaction factor test is shown in this figure. So the first thing is that the cleaning and drying of the internal surface of the mold, and with the help of scoop, place the concrete in upper hopper A. First we will place the concrete in the upper hopper A, and then we will open this trap door of hopper in order to facilitate the falling of concrete into the lower hopper, which is B. We will fall concrete from hopper A to hopper B. The concrete striking to the sides of the hopper A should be pushed downward with the help of steel rod, and then in next step open the trap door of hopper B and allow the concrete to fall into the cylinder C. And then again remove the surplus concrete from the top of the cylinder with the help of trowel. Wipe and clean outside surface of the cylinder, and then we will weight this cylinder. Take the weight of the cylinder with partially compacted concrete nearest to 10 gram, and then fill the cylinder with fresh concrete in layers not exceeding 5 cm in thickness, and compact each layer till 100% compaction is achieved. So to find the compaction factor, we have a formula which is the ratio of weight of partially compacted concrete divided by the weight of fully compacted concrete. As we have done in first step, we did the partially compaction of concrete, falling it from 2 different conical hoppers, and then in second step we will compact the concrete 100% in different layers, and then we will take the ratio of both concretes, and the answer we got will be the compaction factor. So this method is basically used in laboratories, labs, and it gives fairly good results for the concrete of low workability. We prefer this test for the concretes which have low workability. Slump test is for medium and high workability. Compaction factor test is for low workability. And the next is Vee-bee consistometer. Vee-bee consistometer, this separate test used for the method is shown in this figure. In this method, the first thing we do is mix the dry ingredients of the concrete thoroughly till a uniform color is obtained, and then add the required quantity of water. Then pour the concrete into the slump cone. There is a slump cone. Pour the concrete into the slump cone with the help of funnel fitted to the stand. There is a funnel at the top of the cone. So we need to pour the concrete through this funnel. And then in next step, remove the slump mold and rotate the stand so that the transparent dish touches. This is called transparent dish. After removing the cone, we need to rotate this transparent dish. This is the transparent dish. After removing this cone, we will rotate it at the top of this concrete. Then start the vibrator on which cylindrical container is placed. Then we will start the vibrator. Due to vibration action, the concrete starts remolding and occupying the cylindrical container, and we need to continue vibrating the cylinder till concrete surface becomes horizontal. Till the concrete surface becomes horizontal. So the thing we need to note in this is the time required for complete remolding in seconds. In this test, we are concerned with the time. The time required for complete remolding in seconds is required measure of the workability, and it is expressed as the number of Vee-bee seconds, and that time is called Vee-bee seconds, right? So we prefer this test when the concrete is very dry, means very low workability. So there is a comparison between these three different tests. Degree of workability. The degree of workability will be very low if the slump is 0 to 2.25 millimeters, and compaction factor is 0.75 to 0.80, and Vee-bee time is 20 to 10 seconds. And we will call a concrete with low workability if its slump is 26 to 50 millimeter and compaction factor is 0.80 to 0.85, and if the time in Vee-bee test is 10 to 5 seconds, we will call it low workability concrete, and then medium and high. So what we noticed here in this table is that from low to high, the slump value is increasing, compacting factor value is also increasing, but the Vee-bee time, Vee-bee seconds is decreasing. So for high workability concrete, the time will be less. Got it? And the slump value will be high for high workability. So this is the comparison between the three tests for finding the workability of concrete. So the next thing we are going to discuss is the good quality of an ideal aggregate. What should be the qualities of an ideal aggregate? An ideal aggregate used for the manufacture of concrete and mortar should meet the following requirements. Actually, these requirements are specified by IS 383 from the codes of 1970. So the first is it should consist of natural stones, gravels, and sand, or in various combinations of these materials. So a good aggregate should consist of natural stones, gravels, and sand, or in a various combination of stone, gravels, and sand. The second point is it should be hard, strong, and durable. The ideal aggregate should be hard, strong, and durable. And the next point is an ideal aggregate should be dense, clear, and free from any coatings, right? And the next point is it should be free from deleterious substances. Deleterious substances are actually the unwanted substances which are not necessarily important for uh, any aggregate, like organic matters, salts, silts, clays, dust, and sand. So these are deleterious substances. These are unwanted substances. It should be free from these substances. And an ideal aggregate should have no flaky and elongated substances. And the next point is it should not contain any material which is liable to attack steel reinforcement of reinforced concrete, right? So these were some qualities of an ideal aggregate. So that's it for today. In next video we will, let me show you the topics which we are going to discuss in the next class: classification of aggregates and characteristics of aggregates. These two topics which we are going to cover in the next class or next video. So till then, goodbye, see you guys in the next class.